Sometimes you'll see a quadratic with no middle term. Now, for example, we could have something like this: x squared minus 25. Now this is a little like looking at x squared plus 0x minus 25. Essentially the middle term is lost because there's no x's involved in this expression. In this case, the two factors that solve this expression will be symmetric. One will have a positive sign and the other a negative sign. So in the case of x squared minus 25, we'd end up with x and x as before, but we're looking at this number here, the 25, and take the root of it. We'd end up with a 5 here and a 5 here. This would be a plus 5 and this would be a negative 5. Again, we can check this. Let's multiply through. X times x is x squared. X times 5 is minus 5x. 5 times x is plus 5x, and then the 5 multiplied by the 5 will give me a 25, but it's a negative 25 because it's a plus times a minus. These two terms here will cancel out. They'll become 0x. So we end up therefore with x squared minus 25, coming back to where we started. More generally, we'd write down that x squared minus a squared, which is our two squares, would have a solution x plus a multiplied by x minus a. So let's turn to exercise 4.8a on page 76 in your textbook. We'll have a look at question number 2, y squared minus 121. So I'll write that down then, y squared minus 121. So what we're looking for is something of the solution y in each bracket, because y times y will give me the y squared term. That will give me the y squared term there. But I'm now looking to solve the 121. Well, you might recognize that the square of 11 will give me 121. Again, I've got a negative sign there, so I'm going to end up with a plus and a minus to give me my final solution. Now let's look at question number 4, y squared minus 400. Y squared minus 400. So I'll write down again two brackets. We'll put y in the first, y in the second to give me the y squared. I now need to deal with this 400. Well, you might recognize that 400 is the square of 20. So I got plus 20 in the first term, minus 20 in the second term, and I've now got my solution. Finally, for a little bit of extra complexity, let's have a look at question number 8, where we've got something in front of the x squared. We've got 10x squared minus 40. We might need to take a slightly different approach to this. An extra step might be involved. So I'll put down our 10x squared minus 40. And we want to work out what the solution to that is. Well, before we begin, there's actually a common term already. If we take the 10 and the 40, and remember what we did in part 1 of factorising, very simple factorising, we tried to pull out common terms. What's the common term for 10 and 40? What will divide into both? Well, of course, the answer is 10, which will give me a 1 there and a 4 there. So I can pull out a 10, and I'll end up with x squared, so I'll get an x times an x, and instead of 40 I'll get a 4. 4 is 2 squared, so I'm going to get a 2 in there and a 2 in there, clearly a plus 2 and a minus 2. So this is my solution. Remember, the difference is I've got the 10 outside the brackets. Let's finish off then by looking at question 10, 4y squared minus 100. Now why don't you pause the video and see if you can work out the solution yourself first, and then come back and see what the video solution is. Well, I'll assume you've had a go and you've come up with a solution for that particular problem, so let's try it ourselves. 4y squared minus 100. Now we're going to end up with y and y, that's for sure. But before we begin to solve what's inside these brackets, let's see if we've got a common term in front, a common factor I should say, that we can pull out. Well, 4 and 100, 4 will go into 100, and it will go into 4, so 4 into 4 goes once, and 4 into 100 will go 25 times. So we're going to end up with a 4 being pulled outside. Now therefore this is going to be not 100 but 25, and 25 is the square of 5. So we're going to end up with a 5 here and a 5 here. This is going to be plus and this is going to be minus, and that's our final solution.